Okay, in this video, I'm going to talk a little bit about functions. Before you watch this video, you should have read section 1.1 in the book. In this video, I'm just going to give you some examples of functions to clarify our understanding of them, and I'll give you one example of a non-function. Before I give the examples, I want to tell you how I think of functions. Let me set up my document cam here. Okay, so the way that I think of a function is I think of it as a machine. So I put something into the machine, something happens inside of the machine, and then the machine outputs something. So if I have a function f, the way I'm going to think about this is as this machine that does something. It depends what happens inside the machine. It depends on what f actually does. So depending on the function, it could do lots of different things. But I put something into the machine. There's an input. I put this star into the machine, and the machine does something. The function does something, and then it outputs one specific thing, which we call f of star. And the key part of this definition is that when I input this star, exactly one output comes out. So once I tell you what the input is and what the machine does, you should be able to tell me what the output is. There's no question about what's going to come out. A unique thing comes out, and it's only one particular thing. So that's the main thing that you have to understand about the definition of a function, is that for each input, there is a unique output. Okay, so now let me give some examples of functions. So you read in the book that there are 4 ways that you can describe a function. So you can describe a function by a table, by a graph, by a formula, or by words. So let me give you an example of a function that I describe by words first. So let me share my screen here. The desktop. Okay, so I'm sharing the screen, and I'm giving you an example of a function. Okay, and I'm going to describe this function in words. So the function, what it does is it takes a Villanova student, and the output of the function is their year. So I might take as one of you the input and say, oh, what is your year? And you might tell me freshman. So the output of the function is freshman. And so I've described this function to you in words, and now you can apply this function to any Villanova student. You just ask them, oh, what year are you? They might say sophomore, they might say freshman, they might say junior, they might say senior, but it's well defined what happens. It's just their year in the program. Okay, so let me give you another example of a function, and I'm going to describe this one in words again. And the definition of this function, so hopefully you read the syllabus, the definition of this function is we're going to assume that a student has done all of the worksheets for this class and the final project. And this function is going to take as input the number of standards that the student mastered on the exams and give as output the class grade, okay? So you're telling me, oh, I mastered 5 standards. Oh, I mastered 10 standards. Oh, I mastered all 13 standards. And the function is going to now tell you what grade did you get in the class. And so this function I've defined for you by words, but I could also define this by a table. So this is a function that I can describe in 2 different ways. So I'm gonna show you a definition of this function by a table in the syllabus. Okay, so now you're looking at the syllabus. I'm assuming that I've received full credit for participation and for the final project, and that I've missed no homeworks. So I'm looking in the first row here. And so now this function is defined by these first 2 rows of the table. So if a student masters between 0 and 5 standards, well, they're going to get an F in the class. But if a student masters, let's say, 12 standards, then they'll get an A- in the class. If a student masters all 13 standards, then they'll get an A in the class. And so now this function is defined by these first 2 rows in this table. So this is a function where I've defined it for you in words, and I've defined it for you by a table. So this gives you all the information. And just note that for each input, there's a unique output because I'm assuming that I'm in this first row. Okay, so now these are two functions that are maybe slightly different than you've seen in your math classes before. And the point I'm trying to make is that functions can be very general. They just have to take something as an input, and they have to give something as an output. So the input can be something like a Villanova student. It can be how many problems you get right on an exam. It could be the day of the week. And the output can be, you know, whatever, as long as there's a well-defined rule that takes the input and gives the output. Okay, so now let me move on to a function that maybe might look more familiar to you and will be more similar to the functions that we'll see in this class. So I'm going to define a function by a formula and by a graph. So this is an online calculator by Desmos. You can use this during the class. It's very useful. Let me define a quadratic function for you. So my function will be f of x, and I'll define it by x squared plus 5, let's say. So now this function, I've actually defined it for you in two ways right now. First, if you look, I can tell you the formula. The formula is I take as input x, and I give you as output the square of x plus 5. So for example, if I take in 3, then the output I get is 3 squared plus 5, which is 14. And this graphing calculator has given me another definition of the function, and the other definition is the graph. So this calculator has graphed the function for me, and I can look at this graph, and it can tell me what's going on with the function. So for example, I can look and I can see at x equals 1, the output is this unique value, which is 6, 1 comma 6. Okay, so these are some examples of functions. I've given you two functions described in words, one function described as a table, and one function described both as a formula and as a graph. So let me finish this video by telling you an example of something that's not a function, okay? So the key point is that a function takes as input something and gives me a unique output. Okay, so let me give you an example of something that's not a function, that does not satisfy this rule. So I'll take as input a person, and I'll give as output their child. Okay, so now why is this not a function? It seems like it's a well-defined rule, but there are sort of two issues with this. The first is that I might say, oh, okay, what's your child's name? And you might say, I don't have a child, right? So the first thing is it might not be well-defined at all. The person might not have any output for this function. And then maybe the more serious issue here is that there might not be a unique output. So if I ask a person with 2 children and I say, what's your child's name? They're gonna say, well, I can't answer that question. There's not a unique answer that I can give you. And so the issue here is that for a given input, there's not one unique output. And so this is not a function.